All right, welcome to worksheet number 7. Before we begin, I just want to do a little review and make sure we're on top of some of these ideas. And when we look at our trig functions are going to be of the form some f of x equals a times, and I'm just going to use sine here. Now this could be sine, cosine, tangent, etc., times b times x minus c plus d. Now all these pieces again have a meaning. Right there again, this is my amplitude. Talks about how we stretch it vertically, how it's stretched. The b value, a lot of people get this confused and they think that's actually the period. It is not the period. Remember, period is equal to 2 pi over b. Okay, so it's that b value that we're looking for here. Though it does talk about how it is horizontally stretched or squished. So it's a stretch or squish. All right. The c value in here, and again, we like to always have that little negative in front because it helps us think about going opposite. This is telling us how it's moving left or right. But again, what we do is we think opposite because of that negative in front. So if it's like x minus 4, they'd be moving it to the right 4. If it's x plus 4, we'd be moving it to the left 4. And then this d, that tells us how we move it up or down. All right, so just some of those are the pieces there. I just want to make sure we review. I just want to go back here actually and just talk about this too. This is for sine and cosine, because remember, period for tangent is just pi over b. And so just have to make sure we emphasize those points. So when we get down here, what we want to do is we've got some parent function, some f of x equals sine of x. And it looks like they're translating it. That's what the t stands for. The t stands for a translation, okay, which means we're moving it left, right, and up and down. We're not stretching or squishing it. So what this is telling me, this is just the directions. This is the roadmap. It says it's moving it, the sine function, to the right pi over 4 and up 2. So what I like to do in terms of graphing this, I always just start off. If I know it's a sine function, I know the sine function goes up, goes back down, comes back up, and that's what one cycle, one period looks like for sine. So again, normally the sine goes up to 1, goes down to -1, starts at 0, and ends at 2 pi. Okay? So what I like to do with these problems is not just re-sketch the graph, but just to change the scales to represent this new sketch. So if I'm looking at this and just moving it to the right pi over 4, well, then what happens is this is now not 0 anymore, and this is not 2 pi. Okay. That this is moved to the right 4, so this is now pi over 4, and now this is 2 pi over 4, or 2 pi plus pi over 4. So 2 pi is really 8 pi over 4, so adding this together, this would be 9 pi over 4. This would have been pi earlier, so we're just going to go pi plus pi over 4. So pi is like 4 pi over 4, so this would actually be 5 pi over 4 at that point right there. Okay. Now, we also moved everything up 2. That's what this is doing right here, is this is going up 2. This one is going, again, right pi over 4. So I'm just going to move everything up 2. So just going and moving everything up 2, these now become 3 and 1. And then 2 would be in the middle there. So there's my sketch of the graph, labeled, etc. here. Now I just want to write the equation for that graph. So, some pieces we need to do is we look up in the top here, and we look at, well, we didn't change the amplitude at all. It didn't stretch vertically or squish vertically. So we still have this as just sine. And then, again, we didn't do any horizontal stretching or squishing, so there is no b value in front. In fact, well, it'd be 1, if you were actually put a number in there. But we don't need that there. So then we just need to look at, well, how are we then moving it right, left? Well, we moved to the right 4, but now remember, inside these parentheses, we've got to think opposite. So I go minus pi over 4. And then I also then moved it up 2. So that's the d part there. So I just go plus 2. And there's my first problem done. Let's look at the second problem. In the second problem, I can tell that we're doing some stretching and squishing because I'm not adding or subtracting anything to the x and the y. I'm multiplying. So that's going to change the amplitude and the horizontal and the stretching and squishing as well too. So again, what I like to do is just start with the parent function. So look at that, go, okay, well, cosine, I know cosine, starts up here, goes down, comes back up, and it'll end there at 2 pi. And we can mark that middle as pi. This is at 0. It's at 0, that's at 1, and then this is at -1. So that's the highest and lowest. That's our basic cosine function. Now, what I'm going to look at here is this is how it's affecting the x. So it's 3 times longer in the x-axis. So everything's going to be multiplied by 3. So if I multiply everything by 3, okay, these now, instead of 0, let's 0 times 3 is still 3. 3 times pi would be 3 pi, and that was 2 pi, so multiply that by 3, that'd be 6 pi. Then, if we look at the y, okay, we're multiplying the y by 2/3. So we're going to multiply each of these by 2/3. So that gets multiplied by 2/3. This gets multiplied by 2/3. 0 times 2/3 is just 0. So that 1 was multiplied by 2/3. That's 2/3. Now this one's -2/3. So there's our drawing. There's our sketch for our new function. Now we just need to write the equation for that. Okay. Well, this one we did. This one we did change the amplitude. The amplitude is that y value there, so that's 2/3 of that cosine. And now here for the b value, that b value that's in there. Now remember, period equals 2 pi over b, so we're trying to solve for that b. My period in this problem is 6 pi. It takes 6 pi to get from the start to the same spot again. So I'll just do a little quick proportion here. 6 pi equals 2 pi over b. You can put that over 1, cross multiply, so you'd have 6 pi b equals 2 pi. Divide by 6 pi, b would be 2 pi over 6 pi. That would cancel. 2 over 6 reduces to 1/3. So that's my b value that goes in here. So it'd be 1/3 times x. And then because we didn't move left or right, I don't have anything added in between. If I did, I'd have something like this. And then whatever add or subtract, put that opposite in there, but there's nothing being done there, so I really don't have to have anything there. I could keep that as a parentheses there if you really wanted to. You could have that as 1/3 x if you wanted to. All right, let's look at another problem. Let's look at number 3 here. This one looks like we're kind of going a little bit, just doing a little bit something different here. We're not actually asked to sketch the graph. We're just going to kind of use these pieces in order to help write the new function. So again, remembering that we're doing sine, again, we're looking at y equals, or I guess it'd be, in this case, g of x equals, remember, a times sine times b times x minus c plus d. So just kind of rewriting that from up above so we can remember the pieces. Here they tell me my period is 880. Well, kind of using the same idea that we did over here. If my period is 880, and I know period for sine is always 2 pi over b, I can do the calculations here to get that b value in the function right here. So this would be 880b when you cross multiply. 1 times 2 pi is 2 pi. b would be 2 pi over 880. Reduce this, b would be pi over 440. Okay, so there's my b value. It says my amplitude is 4. Right, so when I look at my equation, that's simply what that a value is. Okay. But remember now that amplitude, when I report that amplitude, it's always the absolute value of that a value. So it could be either a positive 4 or a negative 4 out front of that sign. Nothing else tells it here it's been moved left and right or up and down, so I just had to put that b value in, which was pi over 440. And then it'd just be times x. There's no moving left or right. There's no moving up or down. All right, we'll try one more because I believe the rest of the problems on the next couple sheets are just review problems from the previous lessons. So this one's just kind of going in reverse. It's kind of giving us the graph. We got to write the equation for that. So what I look at here first is I look at that amplitude. Normally it goes from -1 to 1, but it's going from -5 to 5. So that amplitude is 5 times as much. I also recognize that it starts at 0 and goes up, so that's going to be the sine function. And then it looks like it's starting here at 0, so it hasn't been moved left or right, or it hasn't been moved up or down, because this is also centered at 0 there as well too. So all we have is just a change in that b value. So again, if I could find what that b value is, I can put that in right here, and I can look at that again by doing this whole idea that period for sine is 2 pi over b. And if I look at this, my period here is going from 0 to 6 pi, so that's 6 pi equals 2 pi over b. Cross multiplying and solving, I get 6 pi b equals 2 pi, and it's just like this problem up here. So again, I would see that b would eventually get to be 1/3. So I'd have 1/3 times x as my function for that graph. The rest of these problems are all review problems. Problems you should know how to do. Some problems that aren't trig functions, just to review that. And just reviewing some of the cosecant, secant pieces, cotangent, some more review of period and amplitude and frequency. Some problems, again, we're given the graph, write the equation. These are problems that you would have encountered back in Algebra 1 and just moving, or Algebra 2, sorry, Advanced Algebra. And some more review of some inverse and some law of sines and cosines and solving some quadratics. Wish you good skill in all the work here, and we'll be in touch. As always, if you got questions, submit them or attend office hours. Thanks.